Okay, hello. I'm going to go over the third slide of this exam. It will cover relational and logical operators. These include these two equal signs, the not, greater than, less than, greater than or equal to, less than or equal to. These are used for comparisons. They're not assigning values. It's taking the operand on the left and the operand on the right side and comparing the values of those two to each other. And logical operators include the double and sign ampersand, these two for or, and the not. These are used for Boolean comparisons, whether the two compared values are true and or false. So if you have true and true, both values are true. So it will pass as true. All right, let's go over to C++. So the first one we'll go over, we'll have to make operations here. Variable integer a, we'll give it the value of 3, and b, we'll give it the value of 5. 4 and 5, sorry. So we'll also have to make a Boolean character here. We'll call it Boolean prime. We'll just initialize it. So we'll assign prime the value of a equal to b. So this is prime is being assigned a comparison equal to b. We're going to see out what prime will be. Also going to see out here prime as well, so we see the change, if any. Compile, run. So it turns out that there is a change because Boolean prime is assigned the value of true, which is a value of 1, and then prime here is assigned the value of the comparison between a and b. 4 is not equal to 5, so we have a value of false, which is registered as a 0 here. The next instance of the not equal to there. Equal to b. So it should stay true. So we'll set this to false because the result should be true because a is not equal to b. 4 is not equal to 5. Okay, we're going to save, compile, and run. There we go. Boolean prime is initialized as false, and then it is changed to true because 4 is not equal to 5 here. Now for greater than, less than, and the equal to of those, start with less than, get rid of this. So 4 is less than 5. This should be true, so we should change from false to true. Go ahead and compile, run. So here we go. It starts off as false, and it changes to true because 4 is less than 5. Now if we add the equal here, it should still give us the same result because it's going to still run as less than or equal to. So save, compile, and run. There we go. 0 and 1. And now let's change the value of a to 5. Since it is less than or equal to, this should still give us the same value. There we go. Because of the addition of the equal, if we take away that, 5 is not less than 5, so it should stay false. There we go, 0 and 0, false states. We're going to change this to greater than and leave it here. 4 to 5, we'll change this to true because our results should be false. 4 is not greater than 5. So we'll compile. Right. So there we go. Value prime is true first, and then it goes through the assignment comparison here. A greater than b, 4 is not greater than 5, so it changes to false. Now we have add the equal sign here, run the same experiments, so it stays the same. But if we change this to 5, it is now equal to, it should stay true. There we go. Now let's change this to 7 and this to equals, just greater than. So now 7 is greater than 5. So this should give us a true value. There we go. True value as a result after the comparison. The next section we will talk about here is the assignment, logical operator. You have the double ampersand, which is and, or not, for Boolean operations. Let's delete this. So we will have Boolean A Okay, so we have Boolean A. We'll initialize it here. And A, we will assign it to the values true and false. So here, the ampersand, double ampersand, the and, is taking the left and right comparison. These two are different. True and false should give us a value of false. So now we're going to see out our Boolean expression. Compile and run. So it gives us a value of false because true and false are not equal to each other. They're not the same Boolean state. Now if we change this to true, compile and run, it gives us a value of 1 because both are the same. But if we change it to both of them to false, compile and run, it gives us a value of 0 because both of them are false. Both of them are in 0 states. Okay, now we will go over the OR function here, the OR comparison. This is asking if one of them. So this is asking 1 or 0 is at least one of these values a 1. In this instance, yes. So we should get a return of 1 for a true. There we go. This is true because at least one of these is a true. Now we can assign them both true. At least one of them is true. So we should also see another return of 1. If we assign them both to false, we should see here a value of 0 because neither of them is true. And now we can do the exclamation point. So we will assign Boolean a value of true. False. So false should register as a 0. We can see out A here before we make any changes to it. And then here we will assign A the value of not A. So not false means true. So it should go from false to true. Compile and run, and there we go. It goes from false to true, and we can do this in the other direction. Compile and run. It will go from true, and then since it's not true, which means it's false, it'll display false as a 0. And that is all I have for this section here.